this is where it's at to do. In the second edition, all the examples we're using Excel Miner, now they're using Jump Pro. Okay, she has a book, again, data mining using R, one using Python, okay, but this is a very good book, and you must do the reading. All the reading that I'm asking you to do, you must do it. Okay? Do not wait until week 10 to find out or to tell me that you are behind. Because if you do, I am calling your grandmother, and this is recorded. It usually scares the heck out of me. All right. Core ideas in data mining. And this time we are capturing just this. By the way, legal, you'll have to sign a waiver or something, because whenever you report something it involves humans, you have to sign something, I have to sign something. So Anthony will bring it. And as you will see, I'm repeating a lot of things that we discussed earlier. When you are doing data mining, you are doing many times classification. And classification is when you already know the classes, right? You are assigning things to classes. But many times with classification problems, you are trying to answer the question yes or no. Will the person get a loan? Yes or no. Will the person get a certain disease? Yes or no. And so another type of so classification is supervised learning. Supervised learning can be classification or it can be prediction. Between today and week 2, lecture 2, next Tuesday, I'm going to show you multiple linear regression using JMP. I know that a lot of you, most of you, either have taken that some time ago or whatever. You must review the statistics concepts that I ask you. Sometimes I will be able, the only problem that I have is one of time. Okay? Please work with me, work hard, and you will reap the rewards big time. So, another type of supervised learning is prediction. Prediction is when you try to predict the average price of a house. When you try to predict a specific number, something continuous that can have multiple values, right? In some ways, when you do classification, it's a type of prediction. But when you predict that somebody will be in one of a few classes, that's called category, the classification, right? Another type of data mining that we will deal with is market basket analysis. And this is more of an unsupervised type of learning. Again, I'm repeating concepts that we will spend more time to more detailed work later on. Data reduction is another type of unsupervised learning. I have mentioned this to you before. I very highly recommend to make it easier on yourselves to print out these documents, have them in front of you, and you only add the notes that you need. Listen to my advice. Because otherwise, it's very difficult to write all of this down. Plus, that's why I have the video, and I know sometimes, last time, I watched part of it, and I think it was fair, but I'm trying to get it to capture just the screen, okay, so that when you watch it, it's a lot easier. We will spend a whole week. Anytime I say week, it's 2 meetings, okay, on association rules. A very popular problem with association rules, market basket analysis, is they found out that when people buy diapers and milk, they usually buy beer. In the very beginning, when this result came out, it did not make sense. But when they did some further investigation, they found out that a lot of young couples that have a newborn they buy diapers and the milk for the baby, and because they they cannot go out, they buy beer. This is true. I mean, this is, but you know very well what this is. You know, when you go to Amazon and .com and you buy something, you buy a book, it says people that bought this book also bought this. They use association rules and market basket analysis to do that. Okay? These concepts are being used heavily. I've had students that worked at places and they were using some of the things that we will discuss in the class. How many of you are currently working somewhere? Okay. Do you do analytics?
Not right now.
Okay. But trust me, this is a huge area, and I cannot say enough about artificial intelligence because that's what we are doing. We're doing part of AI. This is the future, and there are experiments being done as we speak in the UK to hook up people to electric, to cables, and do telepathy. Meaning, I guess what we think. This is the next step. It's being done right now. Who will allow? I will not allow anyone to put cables in my head. But you know very well that many people will. The day that we will become robots, this is going to happen to some people. Some people will do that. I mean, there was a doctor who was so smart and so confident, he injected himself with AIDS because he was certain that he came up with a solution. He was wrong. I mean, this is bravery, but it's a little bit, it's not too smart. Don't do that. Anytime you simplify the problem, and instead of having 1,000 variables, you have 40. Or anytime you reduce the number of rows, you summarize them, and you can still do what you want to do. Anytime you do data reduction, that is that is part of unsupervised learning. We will do data exploration via visualization. So to clarify that comment, if you're looking at a histogram or a box plot, and we will go over those, and you will see that there's a lot behind those. So you look at the graphs to explore data. So it's data exploration via graphs, via visualization. Remind me if I go 4 o'clock and we haven't started the quiz that I just think the PAN will be our TA, and okay. Now, so we have 3 types of analytics. Are these the waivers? Do I need to sign one of them too? Oh, okay. Thank you. Sure, I'll do so. Thank you very much.
How big is this class?
30 to 35 students.
Probably people won't have.
Okay, that's okay, no problem. If you can sign, guys, does somebody have the right not to sign it?
They can, but then we could.
If you do not want to sign, then we cannot record. That's it. I mean, that's the legal. That's the legal thing. So pass them around, and if one person does not want to do that, that means we cannot do the recording. I mean, you're not being captured, but legally, because if you say something, you speak, legally we have to do this, that's all, right? So, we have 3 types of data of analytics. We have predictive analytics. Anthony, if you can help me. Oh, now. When I have a PDF file, I cannot use this. I need to do something. This is a PDF file. I need to do something, and I don't know what to do. In Word, it brings up an option, a menu that says pen, and I click there. If I have Word open, then I can do it. But not in PDF. You don't have to do it now.
I'll come back with some more forms.
Thank you. Thank you. All right. So, okay. I was so pumped when I got this thing, and now I don't know how to use it. All right. It's frozen. All right. We have three types of analytics: predictive analytics. Descriptive analytics first. Descriptive analytics, predictive analytics, and prescriptive analytics. No one. Let me just say this without being 100% sure. No one in the university, by no one I mean maybe I'm 99% certain, that no one does prescriptive analytics. And I'll tell you what that is, but we are not going to go over it in class, I don't have the time. Descriptive analytics is based on data that has already occurred. So if I collect everybody's age, or if I collect everybody's salary and then I do things, descriptive analytics, there's no statistical modeling. OLAP stands for online analytical processing, and we'll talk a little bit more about it. SQL stands for structured query language. SQL is very good to know. I used Oracle and SQL for over 20 years, and I created courses in SQL for the College of Engineering. I can do a class if needed, but we also offer SQL in some of our other classes. And I'll talk a little bit about this. When you do classification, prediction, and affinity analysis is another way to say market basket analysis, right? You need to know these terms. For example, in the next quiz, I may say define affinity analysis, right? So you need to know everything that I'm doing in class, and you need to read the book. Why is this frozen? This computer has had issues, so I can go to the task manager over there and say, die. Okay. Okay. So we have descriptive analytics. Predictive is you try to predict the future, and prescriptive is has to do with simulation. I don't know if anybody knows, has heard of Monte Carlo simulation. Prescriptive analytics is used, let's say you want to buy a house and you get, there's different ways to get a loan. You can get a 30-year fixed, a 15-year adjustable rate, ARM, or you can get some other type of loan. In prescriptive analytics, you say, and then you do something called profit loss analysis, which I know nobody does in the business school, which is very beneficial. Now, you do profit loss analysis, and you say this: you play different scenarios. That the rates, one scenario is that the rates do not change, another scenario is that the rates go up, another scenario is that the rates go down. And then you say, well, if I have these three scenarios, and I made a 30-year fixed, if you make a loan at 5% and the rates go up, that's a good thing. If you make a loan for 5% and the rates go down, then people try to refinance. Right? You do that kind of analysis, and you then, before you even proceed to do the actual loan, you see the benefit and the risk if you made a 30-year fixed, a 15-year ARM, or a whatever, something else. Very valuable, and that can be done. That's part of, it's an extension of analytics. It's called simulation, And you do some of it, I think, in some classes. So that's prescriptive. Okay? Okay. We discussed that there are different strategies when you do data mining. This should be called unsupervised learning. Unsupervised learning. See, that is why I got the tablet, so I can write a lot smoother. Oh, that's the snippet, but okay, well, hold on a second. Even though this is not the best way to use it. Okay. So, unsupervised clustering. So this is unsupervised clustering, unsupervised learning, learning. And this has something called hierarchical clustering. So this has clustering. I will get better with this. Clustering under unsupervised learning, and under clustering we have hierarchical clustering and non-hierarchical clustering. So don't worry about this right now. We will speak more about them. The supervised learning, we talked about classification, estimation, and prediction. Estimation and prediction are very similar. This is another strategy, and this is market basket analysis. Market basket analysis, which many times goes under unsupervised learning. Okay? But don't worry about putting this under the right category or not. The important things that I want you to know is that supervised, that classification, estimation, prediction are part of supervised learning, and clustering is under unsupervised learning. And I'm going to actually put market basket analysis under unsupervised learning. Okay? This is what I want you to do. Okay. Now, I am going to be repeating a lot of things that we discussed last time. So today I want to spend the majority of the time going over concepts, and the majority of the time next time it will be jump. That's sort of the pattern, but it will be more detailed. So when you have supervised learning, okay, you can either have classification or prediction methods. The goal, the idea, is to, when you classify, to assign somebody to a group. Assign one of you to freshman, sophomore, junior, senior. Or to predict a salary. I predict a salary. This is, in fact, I will show you supervised prediction with jump. We talked about different types of data, training data, validation, and test. This is optional. Okay? Like that. So we talked about this. Training data is what you know, obviously, you know the outcome variable, you know the target, and the computer, the robot, learns or gets trained from training data. The validation data is where you try to validate the model, and the test data is an additional validation of the model. And we're doing everything, we're doing all of it, so that if we take data unknown to the program, the algorithm, to score or predict them. And I will show that to you next time. So you will see what data mining really is. So simple linear regression is an example of supervised learning. Why? Because we're trying to predict something, right? And I talked about that last time as well. So So here I just talked about supervised learning in general. Here is supervised learning classification. We will do specific algorithms that do supervised classification. Linear regression is one. Logistic regression is another one. Who uses those? Those are used in hospitals big time. And I've had students who were using a specific, even 3 years ago, who were using the logistics in a certain environment, and so that there are companies that use one of these algorithms a lot. It's like the bread and butter of the company. So you have supervised classification, and we talked about that. Okay. We have supervised prediction, we talked about that. Unsupervised learning is, here's an example of an unsupervised learning. If I want to find out who likes jazz, who likes classical, who likes R&B and so forth, I don't know this. I don't know the groups. How many people like jazz? How many people like classical music? How many people like R&B, right? Rock and roll and so forth. So the people that like jazz, I mean, you can be distance is far away, but you're all then, you can be clustered in one group, the jazz group, right? The R&B group and so forth. Now, a lot of times, what people do in real life, they do unsupervised learning to find the clusters, and now that they have the clusters, they have the groups, then they can do supervised learning later. So you can do a combination of different types of learning techniques. So in unsupervised learning, there is no target outcome before you do. I didn't have the groups before, right? But I know that some of you are freshman, sophomore, junior, and senior, so I know the groups. That is supervised, because I know the groups ahead of time. I know the classes. When you do market basket analysis, right, then you're using association rules. So in fact, what you really have is you have association rules, and association rules have many applications. One of the applications is, I've never used this before, so I'm not. One of the applications of association rules is market basket analysis. But there are others. Okay? We will study this, and I will show you. I have very good documentation of this, of all the algorithms, except with using different software. And I will show you what is an association rule and how it's used by supermarkets. Okay? So, whenever the question is what goes with what, that is some sort of an association rule. Okay? It is not an accident when you go to CVS, you go to supermarket, that certain items are put together. Okay? So the way that they put things on the shelves, right? If they know that ice cream and bananas, people buy that a lot, trust me, there will be some bananas outside of the ice cream. That's why when you're in the supermarket, you know how they have bananas in different parts of the supermarket? It's not that they want to sell bananas and they put in different places, no. They notice that somebody who buys potato chips also buys bananas, something like that. Okay? I've done everything in the workplace. I work for a logistics company, I work for a trading, for a utility company, okay? And as we speak, I'm doing a little bit of consulting, helping other schools jumpstart their analytics program. And I have seen the tremendous applications of analytics in data mining. Okay? Healthcare is where this material is used for life and death situations. And that is a great place where new concepts are being used. So when you say association rules, market basket analysis, affinity analysis are the same thing. So recommender systems use association rules. Our records show you bought X. You may also like this. And seriously, you can start your own company just with zero money put down. You create a website, you pay $10 a month, you advertise, and off you go. You have an idea to collect certain data. A lot of companies, you know how they make millions of dollars? They collect data. They do surveys, they do studies, they collect it, and then they sell it. Okay. So, anytime you, if you have a histogram, right? You can have 10 billion rows of data, and you have a little tiny histogram that takes up 1/3 of a page. You're reducing the complexity of the problem. That is unsupervised, because before you had the data, you didn't know how the histogram was going to look like, did you? Also, even if you know the histogram and the data changes, the histogram will change. You don't know how it's going to change. And what you want to have, a very good illustration of unsupervised learning. When you go downtown in the financial district and they have that ticker thing that goes around, they tell you the prices, the stocks, how they go up and down. You know how it's going to look like later on. That's unsupervised learning. Here is why they call it unsupervised and supervised learning. If I try to assign you to be freshman, sophomore, junior, senior, then somebody, a supervisor, can go around and check what you have done. So if you have, let's say, 90 credits, and you by accident, you or somebody, classified you as freshman, somebody will say, the supervisor, there's a mistake. With 90 credits, you must be a junior or something like that. So somebody can supervise and make modifications. But when we tried to find out the jazz cluster, right? If there's nobody to go around and tell you, you really like R&B. I mean, that may be true, but how is somebody going to judge you, right? It's more difficult. Unsupervised means there's no supervisor that can go around and easily modify or reassign you to something else. So, in all of these instances, when you reduce the number of variables, you reduce the number of columns of variables are the same thing. And we will talk about this. You reduce the number of rows, you do clustering, you have unsupervised learning. When you create any type of a graph, as we did, that is unsupervised learning, always. Scatter plot is used to find out how two numerical variables are related. So when you look at graphs, you look at graphs to explore data, to find out, right, what is wrong with data. I sent you an email to buy this book and to study chapter 3. So this time around, I scanned the pages for chapter 3, and I apologize because it's tiny. I had big time problems. If I tried to enlarge it, I couldn't get some of it. But this file is online, and online you can enlarge things, okay? It's called, chapter 3 of this book is called Dirty Data, because when you get a data set, you may be missing values, you may have incorrect values, and so forth. And because the data needs to be cleaned up, they call it dirty data. It's a very good book, right? You can buy it for under $50. So I'm asking you so far to buy 2 books, right? This is one, and that's the other book. If you get an e-book cheaper, some get it. Okay. The process of data mining. So, in fact, next time I'm going to follow this process to show you how we can do multiple linear regression with JMP. That document is already online. Multiple linear regression with JMP. This has the whole thing from beginning to end, and we'll use these files. Okay. Now, I also spoke about the dashboard. This is where the recorded lectures are, right? I put it in YouTube finally because I stored it this year. So this is the thing. So you can go back, and it's on YouTube, so I disabled the comments because I want to say something else. I can enable them, I don't care, it doesn't bother me, but for now I do. DMSP dashboard. You click jump. This is, I'm in Chrome, you click that, you click this. It will ask you for username and password. Maybe it will be, it will say up here Windows security like it does. Password. This is the system password, right? For the system network. If you have a Mac, if you need to install remote desktop something, right? Now, this is good, but there's only one little tiny issue. Okay, this is one of the data files. So if you click help, and let's say, the thing is this is on a server somewhere. If I want to open a file open, this does not look at your desktop. It looks for file folders on the server. I found a quick workaround. I'm working, Anthony's helping. So, and I know how to handle it. If you want to open up a file, right, a data file, you can click help sample data library. These files are on the server. To bypass, see what you can do is you click. See these folders? I created folders here, and I put up files. Oh, wait, files. Ooh. So I put the files there, the files that we need, and I'll keep doing that so that bypasses the whole issue, right? So I can double click here, and poof, there you go. So all the files that we need, I put them out there. So when you, once again, if you want to use, now this jump, this means that you do not have to install jump on your laptop at all. It doesn't care if you have a Mac or Windows. That is the beauty of this. This dashboard is not a well-known fact. It is a diamond in the rough. We worked a lot over this summer, and I was very heavily involved with that. Let's leave that open. And I'm the one that put this allow you to connect to Oracle. If you need to use a database for one of your courses, talk to me. I will give you access to Oracle. Oracle resides on the server, and you do not have to install the software on your laptop at all. Anything you see up here, you do not need to install it. And it doesn't care if you have Windows or a Mac. We worked a lot. Anthony did a lot of work, and we had a couple of other people. But it's basically me and Anthony that did the majority of the work. If you want to use R, if you want to use MATLAB, if you want to use, where's Python? This is Python, right? You can use it from here. And so you already have it, right? But I want you to know that when you go to jump, then you can, if you need a data file, I created these folders, because if you do file open, it doesn't look at your desktop, right? But I put all the files here, help, sample, data library. So this is where the jump files are. But if you go back all the way to the left, where it says desktop, you'll see data mining Dimitrios. That's why I put my name, so that it's easy to recognize, and I'm going to put the files here. And also, this book that I asked you to get, Fundamentals of Predictive, that has data files too. Well, I put them here, you see this? And this is where these data files are, and I tap this document. No, it did not. So a lot of times I do this. So. But if you double click here, this has the files. I created the copy. This has the files that are used in the examples in this chapter. Right? So you can get the access, the files this way that you need. So we're doing a lot of big things here at the school, so that you know, for your benefit. Okay. So when there are different methodologies when you do data. One of them is called SEMMA, and SEMMA stands for Sample, Explore, Modify, Model, Assess. And even though I hate abbreviations, I created a company called AAA, Anti-Abbreviation Association. So I'm not going to test you what SEMMA stands for. SEMMA is a methodology by SAS. JMP is a SAS product. And another of the icons here on that dashboard said SAS. So we put up a lot of SAS products there as well. SAS is an incredible data mining analytics. It does a lot of things, and it's there. So if you want to do something in a powerful language, SAS is one of the top programs out there. Having in your resume that you're using JMP, that you're doing SAS, is going to help you immensely. I worked over 20 years, and I worked with many companies. SAS is being used extensively. Is it the most widely used analytics program out there? Not necessarily. There are many other fantastic products. SAS is one of them. Okay. So, when you are trying to do a project, you need to understand what it is that you're trying to do. Okay? Are we doing this one time? This will be ongoing? Is this for a small department? Is it for the whole company? Get your data. Okay? And one of the questions was to do random sampling. I better leave SAS. Okay. In fact, I want to keep using the SAS, the JMP here, the one that I'm accessing through the dashboard. There you go. Because I want to show you to do a sample very quickly. Right? This is a table, right? How do you do a sample? Tables, subset, and you click here and you say I want a sample of 9. Right? You click OK. Poof, you get the sample of 9. This is a random sample. That's it. Right? Here, what I want you to become very, very independent. I know very well when you try to find out, different types of expensive cars, you guys find it. I don't care how hidden it is, you find it. You go to Google. If you have a question on how to do something, you can Google random sampling in JMP. That's it. Learn to do this. Okay? But I also have the documents online on Blackboard to do all these things. So let me leave that open because I'll be doing it too. Okay. Explore cleaning the data. Dirty data. You need to clean it. You can have missing data. You can have unreasonable data. You look at the scatter plots. Is the data consistent? Are the units correct? All those are very important issues. You reduce the data. We will talk about principal component analysis, where if you have 50 variables, do we need all 50 variables? Maybe can we use 10 and get 90% of what we want? Right? That's principal component analysis. You know where principal component analysis is being used? When, many times a criminal goes to court and they ask the witnesses, and based on the the questions and the answers, there's an artist, they paint half of the face. What they do is they take that, they digitize it, they put it in a computer, and they run that against pictures of criminals already in the database. And then it finds likely matches. And many times this thing works. These artists are amazing. You tell somebody that this guy is scrawny, they have a beard, they have swollen chicken. It's unbelievable. Also, it's being used a lot, principal component analysis, when they have part of an animal, they have a leg bone or something, and they use that, and they try to make inferences. They take, if they have the leg or the left hand or something like this, and they have a partial picture of something, and then they run algorithms, and they come very close to predicting how the thing will look like. So principal component analysis is used by FBI, CIA, security forces. So the next question is, so we have other issues here. You need to decide if you have a classification, if you have clustering, you have prediction. Sometimes that's easy, other times that is hard, other times you can do one of many of these. But we will talk about basic, right? If you want to decide if somebody here is freshman, sophomore, junior, etc., that's classification, which means supervised learning. If I want to predict your GPA, which can be anywhere, let's say from 2.5 to 4.0, would be aim of this, I want to predict a specific number. Prediction means supervised learning. If I want to find out the profile of a student that gets an A, study many hours, sometimes people are brilliant. Right? I have a brother who has photographic memory, and he, for the whole semester, he took half a page worth of notes. I filled out the whole note. There are people like that. I had friends like that. Half a page of notes for the whole semester. I said, what? I'm not one of these, all right? So, if you want to find the profile of somebody who will pay the mortgage on time, you want to find the profile of a criminal, a serial killer, then you use characteristics about, let's talk about criminals, right? Characteristics about these criminals, right? They have this issue, that issue, and so forth. And then you try to cluster them. And at times, there are very serious mistakes being made. I mean, it has been recorded many times, and I saw this. The FBI went, broke down the door, thinking it was a criminal. It was an 85-year-old lady on the rocking chair sleeping. Mistakes are being made. They're not nice. But a lot of times when the police says we have a lead, they are doing these kinds of analysis, and it says that is a likely person, right? I was pulled over one time because I fit the profile of somebody who was criminal. Pulled over. And you know what the funny thing is? When the guy looked at my name, he got even more upset. So what? There was somebody called Dimitrios Fotiadis who was opening up a pizza place, burn it, collect insurance. Open up another pizza place, burn it, collect insurance. I got a letter at home from the FBI. You have 48 hours to be arrested. And I said, I don't even know how to make pizzas. In fact, my family had a pizza at some point, and I want to help out. They said, take the pizza out. I opened the door of the oven, I put my hand in, I took it out, I got burnt. I said, get out, you can't do this. I said, give me another chance. I went back there, bring the pizza out. I opened the door, I burned myself twice. Go back to washing dishes. So, if you try to find a profile that is clustering, is usually unsupervised learning. So you choose the technique, then you write, then you use software algorithms, and we will use plenty of them to come up with, to get a model, and then you use it with real data, right? And you see how accurate or inaccurate you are. So this is the SEMMA methodology. You have your data, which usually resides in a data warehouse. You select the data that you need. So this is the data that you say I'm going to use. Then you clean them up. This is cleaned up data. You may need to do some transformations. We'll talk more about this again. Then you have transformed data, and this is when you start doing data mining. You look to find patterns, and you collect knowledge. When you say, and many times, you know, with the police, they look at the patterns, and many times they're not far from finding the person. I mean, okay, when there's a killing, many times they suspect the husband or the significant other, because it has happened many times, right? And so it's very unfortunate. It's a terrible thing, but that's what the pattern says. And they many times have innocent people, they tell them, don't move, don't go anywhere, stay there, because we want to talk to you. All right. Another methodology is called CRISP, cross-industry something. Question in a quiz is, what are the two types of methodologies that we use? SEMMA and CRISP. I'm not going to go over that. Preliminary steps, we will use the Boston housing data. This is Boston housing data set. This is a real data set that was collecting. That's a very popular data set in the analytics data mining. It has about 540 rows and so forth or so. And when you start the project, and by the way, if you go to interviews, please contact me. I can help you out. I'll do the best that I can as to how to approach things. If they ask you, have you worked with large data sets? Or have you, yes, you want to ask them, what do you mean by large? You will be surprised. Some people will say, 200 records. If they ask you, is 2 billion records a large data set? What would you answer? Don't be afraid. If you say it's large, no, it is not even a dot. 2 billion, 200 billion, no. So then they ask you, what's a big data set? Something that's in the terabytes. Okay? You can look up terabyte, how big it is. Terabytes, exabytes. Okay? Because the data, the problem today, the problem 20 years ago, we did not have enough data. Today, the data grows so fast that the problem is, how do you clean up the data? This course will challenge you in many ways. People come and tell me, I wasn't challenged. And they get an A. People are like that, right? But I hope you will learn a lot of things. This is one of those data sets that's popular. It's very, very small. And initially, these are the columns that we have. Initially, this is not in the initial data set. Okay. These are averages. This is an average. What they did, they divided the serial boson into tracks, not tracks, tracks. Okay, so each line, the serial boson is divided into 21 neighborhoods. Each neighborhood is divided into tracts, and this is used a lot in voting. So a tract may be, for example, one street, Columbus Ave, from 2,000 Columbus to 500. That's a tract, right? So each of these rows represent the average. CRIM is the crime per something. this is called metadata. Metadata, like Meta World is the basketball guys. This guy maybe was with analytics ahead of his time. You want to know what each column means very well in real life. Okay? So this is the per capita crime rate by town. In fact, when this was done in 1974, they were asking people directly, are you black or not? And some of these questions today can be racist, right? And so zone is the proportion of residential land zones for lots for over 25,000. So this is the meaning. This is it's one of the most popular data sets in analytics data mining. And this is where it exists. It has 506 cases. Yeah, so, so here, what this was used, this is in 1974. 1974, actually in 74, that is when we came to this country, and in 1 year, by 75, my parents bought a 3-decker for $24,000, which about 10 years ago, it was worth 600, 700,000. Buy property. Build your credit, buy property. Now, so you have these 14 variables right here. And what you want to do, this is the median value of the house, right? So the idea is to use these 13. This is what I'm going to go through and show you with jump next time. You use these 13 variables to predict the median value. Supervised learning prediction. Now, another thing that you can do, and this is explained down here, if the price of a house is less than 30,000, you put a 0. This is a categorical version of the median value. If the price of the house is greater than 30, then you put a 1. So now, instead of predicting, so this was not in the initial table, but you can create this column based on that. If you want to classify a house as, let's say, cheap or expensive, the problem is supervised learning classification. Because you classify as being cheap house, less than 30, expensive house. Okay, you see, same data, but I did. So, when I take this, when I say this right here, when I say if median value is less than 30,000, then put a 0. If it's greater, put a 1. I am taking this column and I'm transforming it. That is transformation. Okay? And this can be done very nicely with jump. Okay. I'm going to go through multiple linear regression. Multiple linear regression is when you do prediction, right? So supervised learning, prediction, multiple linear regression is one of the many ways to do prediction, and I'm going to show that to you next time. We did this sampling from a database. Whenever you see the word sample, you want it to be random sample. Very quickly, the worst companies on the face of the earth, and I always want this to be recorded, are the pharmaceutical companies. And they always pay a penalty. And what they do, it's in the billions of dollars. And you know what their thinking is? We will sell a pill, we will make $50 billion, and we will pay a penalty of $2 billion, but we still made a profit of $48 billion. This is the thinking process. Tonight, after you guys, I teach biostats, I teach pharma students, right? And pharmacology students, masters and PhDs. And we talk about it. Because I've taught this material online, and there was a study many years ago, one of the pharmaceutical companies whose name I forget, I would mention it if I remember it. They came up with a hormonal treatment for women. They gave it to women, and they said these women felt better. Then they sold the drug for a few years. 80 women died in a few years. This is a real story. A very smart reporter who had taken statistics asked the following question: did you get a random sample? And the answer was no. What the pharma company did, they took very sick women. They gave them the treatment. These women were very, very sick, close to die. And they could only get a little bit better. And that's what the pharma used to advertise. They did not use a random sample. They took a very non-random sample. As a result, people died. And that is very bad and very unethical. Right? When one person dies, that is terrible, regardless of who that is. 80 women died who were, I think, healthy, right? And they took this because they want to feel better, poof. And it was all because the sample was not random. We're getting very close to 4 o'clock, 3:56. Let me draw the line here. Put everything away, and these are definitions. Make sure you put your name. There are definitions, multiple choice. There are 10 multiple choice, and there's some fill in the blank. I asked a couple of questions to see, I think I talked about mean and median. There may be 1 or 2 questions that I did not speak much about, but I will take care of that afterwards, okay? So, put everything away. You have until 4:30 to do this, all right?